Now we are going to discuss about regression analysis. So the objective is to determine relationship between one or more IVs or DVs. For example, you get one or more IVs and one DVs. For example, you want to put many IVs tapi DV dia satu saja. This is the example of regression. Predict the value based on the X to predict Y lah. That's mean Y is equal to MX tambah C. So the basic understanding of the regression is Y is equal to MX tambah C. Tapi ini kita belajar at maths dulu. For the regression model is actually slightly differ, which is the Y is equal to beta naught plus beta X1 and so on. So beta naught ni adalah you punya slope lah. Sorry, not slope. You punya yang merentas paksi Y. So BX ni, B ni adalah you punya slope, X ni adalah you punya factor coefficient, Y ni adalah you punya predicted value. Never mind, we are going to see that one. So this is a scatter plot. The scatter plot is actually one of the graphical tools to measure the correlation between two variables, numeric variables. Itu ada dipanggil sebagai scatter plot. Okay, for the regression using the similar huruf ataupun alphabet, similarly like the correlation, which is we call it as a R, but regression we call it as a R huruf besar. Okay, the difference is the R besar lah, huruf besar ni R dipanggil sebagai regression. So if you read a journals and then you find out they give you the R, which is the big alphabet R, that's mean it is a regression models. So it's used to make a prediction. Okay, when you run any regression analysis, we got two hypothesis testing. So we got two hypothesis testing. The first one is the hypothesis for testing the regression models, and then the next one is for testing the slope. Slope is actually we want to measure whether the slope is exist or not exist. Regression model is actually we want to making a predicted models. Okay, that one never mind. I'm just explaining to you. If you understand, understand lah. If you don't understand, you can come back and see me to discuss more lah if you use this analysis. Okay, so what you expect, the first one, you are going to produce a prediction equation. This prediction equation will be given to you if you are using the regression analysis. For example, this is Y hat is equal to 7.533. 7.533 is actually yang merentas paksi Y. This is called intercept. Okay, in the statistic we call it this one constantly intercept. And then 0.18 ni is the first factor. This one is the second factor. So how many factors you have? So this is our prediction equation. So we can write our equation. Actually equation is the same lah. Macam MX tambah C ni. But the difference is this one we got so many X lah. Because X is considered our multiple factors. Because the function is actually to make a prediction. We want to predict the Y based on the multiple or single X. We got one single X or many Y. Or many X. X is what? Factor. Okay. So the hypothesis testing, the first one, we are looking into the regression model. So regression model, we want to test whether the regression model are fit or not fit. That's all. And then the slope also is the same. We want to see the predicted values that is significantly influence or significantly predicted our Y. Y ni kita punya kesan or outcome. So this is the regression analysis, the regression as stated here. And then we have two important characteristics of the SLR, simple linear regression, which is the first one we call it as the multiple correlation coefficient or R. R besar ni menunjukkan kepada value kekuatan dia lah, besar mana dia influence our prediction equation. And then the next one is the coefficients of determinants. So these two item ni, R and R square. This one is R square, this one is R. The coefficients of determinants is actually explaining how many variables been explained for Y by X. You don't understand, never mind. Two hypotheses, regression and slope model. After you run this data, inshallah you will understand a little bit lah. So this is the hypothesis that you want to establish. So the first one, our hypothesis will say that the regression model are not fit, and then the alternative, the regression model are fit. That's all. So our null will say that regression model not fit, and then our alternative, the regression model are fit. So the slope, we are going to use the similar slope like what we did in the correlation. There are some positive prediction, negative prediction, and so on. Okay, that one is the regression model and slope. So hypothesis, the first one, hypothesis test for the regression model. So this is the step. The step is actually look into the statistical F, which is the significant F on the ANOVA table. So this is the idea. Okay, and then this is the conclusion. Regression models fit. So the first one is regression model. The second one is slope. Regression model and slope. RS. R, regression model. Fit or not. S adalah slope. Itu adalah cara nak ingat lah. RS. Lepas huruf R is huruf S. So R, regression model. And then model ni maksudnya apa? Your model fit or not fit. It seems like you want to test clothes, whether that clothes is fit or not fit with your body. That is just one example lah. And then if you reject your null hypothesis, then you will suggest that the regression model is fit, whereas there is significant relationship lah, macam correlation juga. Okay, this is the additional analysis, which is we call it as a coefficients of determinants. Coefficient of determinants. Coefficients of determinants actually how many variants being explained for y by x. So we have the value from 0 until 1. 0 until 1 will give you some ideas whether how many variants lah, berapa banyak faktor-faktor ini diterangkan oleh faktor x itu tadi. For example kan, you ada 5x. X1, X2, X3, X4. X1 contohnya years of experience, years of working what, age. This one is salary, for example lah. And then you want to predict Y. Y is job performance. Example. So you find out that the R square is equal to 0.8. That's mean 5 or these 4 factors are more lah. Sebab 0.8 ni consider approaching to 1. Correct? So that's mean it is a very highly significant predictors. It's become a very good indicator for you to predict job performance. Maybe when you got something to do with the X1, you increase the age and then the job performance will increase and so on and so forth. So that is why we need to do the regression. We want to make a prediction based on our available data. And then the next one is the multiple correlation coefficient. Multiple correlation coefficient is also being explained similarly like a Pearson correlation, where we want to look into the correlation between the X and Y. Okay, the next one is actually hypothesis testing for regression in terms of the slope. So the first one, we are looking into the regression model, whether it is fit or not fit. And the second one, we are looking into the slope, whether the slope is exists or not. So if you reject your null hypothesis, there is significant relationship. You are talking about the relationship between the IV and DVs. Okay, significant contributions of X toward Y. X ni maksudnya boleh banyak X, Y tu boleh satu Y sahaja. Okay, let us do some analysis. Boleh? Kita bersama-sama nak ke tak nak? This is just an example, a simple one example. The first one, data were collected from randomly selected samples to determine the relationship between average of assignment score. This is taken from previous examples, and the test score in the statistic distributions of the data presented in table below. Derive the predicted equation. That is the first question. The next one, test the hypothesis for alpha is equal to 0.05 and then determine coefficients of determination. This is called R square. And then multiple correlation coefficient is the R besar, R, big alphabet R, and then interpret the two values. So we are going to see that one also. And then the last one but not least is actually to test the hypothesis for the slope. So we got several indicators that we need to settle down with this kind of analysis of data. Okay, the first one, you need to set your data first. So go to your SPSS and open your new windows or your new file data set, and then make it blank like this, and then we are going to key in our data. We key in together. Can we do that? Okay, let us do together. The first one is the variable. You put here is assignment. Actually, it's the same from the previous data set. And then the next one is the test. Okay, and now you are going to put the values 8.5 and then 88. The next one is 6 and then 66. The next one is 9 and then 94. The next one is 10 and then 98. The next one is 8 and then 87. And then the next one is 7 and then 72. The next one is 5, 45. The next one is 6 and then 63. The next one is 7.5. And then 85, and then last but not least is 5 and 77. So we are going to make a prediction. How we want to predict? Actually, we want to predict if you got this kind of marks in your assignment, then what will be your test? You know, that's why I've said to you before, we can make a prediction also based on whatever that you have data before, and then perform. And then we can predict what happened to our patient or what happened to you, what happened to your marks and so on. So this is the analysis using the what we call it as a regression analysis. So follow the step as shown inside the Nila slide kan. You want to copy the apa nama, the steps also, you can follow this one. Never mind, I'm going to show you live how to do that. The first one, you click here analyze, you go to the regression, correct, and then you go to the linear regression. And then what is our dependent? Our dependent will be assignment, correct or not? Our dependent will be, sorry, our dependent will be test. Sorry, my bad. You got where is it? Analyze, regression, linear. Okay, the first one, put your dependent, which is the test, and then assignment as your independent, which is your factor. Okay, this is just an example. And then there are lots of adjustment that you need to set for this radio button. However, for this particular example, I'm just going to click OK to run it overall lah, like that. Okay. So just click OK button, and then this one they are using the enter method. So they have the stepwise regression model, forward regression model, backward regression model, whatsoever that that one I hope that you can learn in the sekolah pondok lah. Okay. The next one is the enter method. So this is the enter method. This is the R value. This is the R square. So the R value actually is what? You can try to look into this. Okay, you can look into this. So your R value is actually your Pearson correlation lah, your multiple correlation coefficient. So this one, multiple correlation coefficient is actually your R. Your R if you are using the correlation. This one R besar ni adalah you punya multiple coefficient correlation. Dia sama macam you punya Pearson correlation lah. Ni Pearson correlation ni 865 Okay, the first one that we need to understand is this table, the ANOVA table. ANOVA table are talking to you about the slope, regression slope lah. The first one are talking about the regression model, whether the regression model are fit or not fit. So I'm going to ask you, less than alpha or more than alpha?
Less than alpha.
Reject or fail to reject null hypothesis? Reject. So that's mean we are going to say that the model fit or not fit? Pandai. The model is fit lah because we reject the null hypothesis. So that is the first thing that you need to understand. The model are fit. Okay. The second one is the coefficient. Coefficient are looking into the T statistic. This one are going to suggest to you whether the factors that we are interested in is significantly correlated or not significantly correlated in our regression slope. So based on this data, we can see this one is less than alpha, right? So if less than alpha, that means it's one of the good predictors lah. Dia akan predict you punya what? You punya Y. It's a significant predictors. So if you see here, we got constant, we got assignment. This one is your X. So macam mana nak buat dia punya predicted equation? Y is equal to 18.052 plus, because no sign of negative here, plus 8.257x. So this is our predicted equation. Understand or not? So if you got anything to do with the X, and then you can predict the Y. That is what I'm talking about. That is the regression model in the simplest explanation. You got now or you don't got anything? That's why we need to do the regression models only if our data are sufficient. I mean a big sample size, and then our predicted variables are very good, and so on and so forth. So let us look into the discussion of the items. So the first one, as indicated in the question here, we need to indicate or we need to report the predicted equation. So it's similar like whatever that I did just now, which is the predicted equation is 18.052 plus 8.257x. So this one lah. So the first one is the regression model. We are making decision based on the significant F. So conclude that the regression model is fixed. So that is correct. And then the next one is the coefficient of determination. Okay, I forgot to tell you about this thing. We call it as the R square. R square is actually explaining how many variants being explained by how many variants being explained by X to predict Y. So in this case, you can see here is 0.7. So 0.748, this is suggesting 1, 2. You times by 100, you got it around 75%. So that's mean our X can predict Y 75% explain variables, explain variance. So that means it kind of huge lah, big. That mean X ni adalah salah satu faktor yang besar untuk mengetahui apakah Y yang bakal kamu dapat. Okay, that is the explanation for the coefficients of determinants, which is the R square. And then this is the hypothesis, the second hypothesis for the regression models. testing for the regression model. So based on this, we are going to say that regression model fits the data. Only already been explained before. Coefficient determinant already explained. Okay, sorry. Hypothesis testing for the slope. So in terms of slope, we are looking into the T statistics. So from here, we want to conclude the assignment score of X contributes significantly towards the score of test. That's mean it's a significant predictor. Sometimes our X might not be a significant predictor to our Y. Okay, so this is the second example. So you can do it at home if you want. I hope that none of you will do it lah. Because of the ability to understand is kind of taking some times lah. Never mind. We proceed with our own data. So our own data, unfortunately, I just want to say to you, we cannot run anything by regression. You know why? Because after we done the correlation, most of the correlations are not shown any significant correlation. You see, when it's not significant, then we'll stop there. We cannot extend to the regression model because it will give the same meaning. That means you cannot predict that one. If you don't believe me, you can try lah. You put here analyze, regression, you go to the linear, and then please insert your B total and then include any aspect of this one. So this is the example that I mentioned to you before. If we want to do something to do higher than our level now, so we need to include more variables in our model. So now we are going to click OK button and everything is